Good morning, students. Today we will discuss about the concept of valency of an element. It is written here. Now think about an element or rather compound first. Aluminium oxide. The formula is here Al2O3. Al stands for aluminium and O for oxygen. All of us know that. Earlier you have learned how to make this formula of a compound. First of all, you have to write their valency of each element at their below them. For aluminium, its valency is 3, and for oxygen, its valency is 2. Now, by the crisscross method, this valency of aluminium will go to subscript of oxygen, and valency of oxygen will go to the subscript of aluminium, making it Al2O3. Now the question is how this valency 3 is coming, or how we can come to know the valency of oxygen is 2. I am trying to explain it for you. Now first of all, aluminium, from the periodic table we get to come to know that its atomic number is 13. So therefore, as we have learned, number of electrons present in aluminium will also be equal to 13. Now we have to go to its electronic configuration, or rather arrangement of electrons. In the very first shell, that is in the K shell, it will be fulfilled at first. It will be 2 electrons. So how much left? 11. Out of this 11, the second shell can occupy maximum 8 electrons, means L shell. So these 8 electrons are placed in L shell. So how many left? 3. So these 3 electrons are placed in M shell. So 2 plus 8, 10 plus 3, 13 electrons fulfilled. Now the condition is that each and every element try to remove out maximum 3 number of electrons from its outermost shell to obtain maximum 8 electrons in its outermost shell towards stable electronic configuration known as Octet Rule. Or it can also gain 1, 2 or 3 number of electrons. Maximum 3 it can release out, or maximum 3 it can accept. Now here, if I release out these 3 electrons outside the outermost shell, if I release out these 3 electrons, the outermost shell will contain 8 electrons. So it will be transformed into a stable noble gas configuration, that is complying with the Octet Rule. So the number of electrons, the definition is that the number of electrons which can be released out or accepted from the outermost shell of an electron of an element, that is known as its valency. So here, upon releasing out 3 electrons, it is getting stable configuration. So the valency of aluminium becomes 3. Now coming to oxygen, atomic number 8. So number of electrons will also be 8. So the arrangement of electrons is like this way. In the first shell, means in the K shell, it will be 2. The rest 6 are arranged in the L shell. So if I 6 plus 2 make it 2, it will become 8. Here you see it will become 8 if I induce 2 electrons in the outermost shell. So from this we can come to a conclusion that the valency of oxygen is plus 2, or rather you can tell it is only 2. Here it is, the valency of oxygen is 2. Similar way, if we think about sodium chloride, the sodium atomic number 11, so the number of electrons is also 11, so the arrangement of electrons should be 2, 8 and 1. So if I release out 1 electron out of the orbit, the outermost shell will become complete with 8 electrons. So its valency will be equal to 1. On the other hand, if I think about a chlorine atom, its atomic number is 17, so number of electrons also 17, arranged in this way: K shell 2, L shell 8 and M shell 7. So with this 7, if I add one more electron, it will become 8 in the outermost shell. I cannot release out the 7 electrons. Rather, it is easier to accept or induce one more electron to make it 8. So the valency of chlorine is equal to 1. Now what will happen if there are 4 electrons, for like carbon, atomic number 6, number of electrons 6, so arrangement will be 2, 4. This arrangement is represented as by this way, by putting dot around the symbol of that element. This structure is known as electron dot or Lewis dot structure of atoms. These 4 electrons are arranged in this way. Now in this case, it can neither release out 4, what we will do, release out 4 or accept 4. We are in hesitation. For that, it will share its electrons with other elements. Just like, think about it, hydrogen, it is having 1 electron. If it release out, it cannot accept 1 more because no more space is there. If it release out, there will be no existence of hydrogen atom. Now one carbon atom is sitting here with 4 electrons in its outermost shell, inviting 4 hydrogen atoms to share their outermost shell electron with it. Here you see, carbon is using this electron of hydrogen. This electron is sharing with this one, and this one is sharing with this one, and this one with this one. So by this way, here you see, if one carbon atom can share the one outermost shell or the only electron of hydrogen, it can become 8 electrons, 2 plus 2 plus 2 plus 2, 8 electrons in its outermost shell. On the other hand, if you think about hydrogen, it will use, by using the outermost shell 1 electron of carbon, it is having 2 electrons, that is of a stable configuration named as duplet configuration. By this way, this is forming a compound called methane, CH4. This sharing of electron can happen only if there are 4 electrons in the outermost shell of an element, and this formation of bonding is known as covalent bonding. So by this way, we will come to know the valency of the elements. Thank you.